Hello, physics, linear momentum. This is an interesting question. That question says that a rocket of mass 3,180 kg is traveling in a outer space with the velocity 115 meter per second, and to alter its direction perpendicular to its original direction. If the rocket gases are expelled at the speed of 1750 meter per second, how much mass must be expelled? So we have to find the mass of the gas, mg, uh, gas. Okay, so we have to find this one. So suppose this rocket is going, this is the original direction of the uh, rocket, v original, and we want to change this direction to this one within an angle theta, which is 35 degrees, which is 35 degrees, so angle theta, and this is v final. And in order to achieve this final, so we have this uh, velocity which has to be added. So we say r. So here we will use Newton's third law. So in order to move this one, so we have to have a conservation of momentum. Conservation of momentum. Suppose a mass m with velocity moving this direction. So in order to conserve, the same mass has to be gone in this direction as well. So v minus r. So momentum initial I is equal to momentum final, or pi is minus pf is equal to 0. So this one mass, so the gas mass is v minus r, v minus r velocity, and m of the gas, this is one momentum initial, and the final minus this m gas is coming from the mass of the rocket, minus this mass of the gas into vr. So because these are values, so we will not put the sign of vectors, so it's equal to 0. So if you bring the mass of the gas on one side, mass of the gas, which is equal to mass of the rocket into v of the rocket, which is v original, and divided by vr minus v of minus r. So v of r, so v of r is v of r is v original into tangent of theta. So if you substitute the values, This one is equal to, this one is 3,181 kilogram multiplied by VR. VR is 115 into tangent of 35 degrees into VR again 115 into tangent of 35 degrees minus uh, a V of V is VF V0 V0. So this is VR and this is 1750. So if you calculate this one, so this will be equal to 1.40 10 power 1 kg, which is equal to 14.0 kg. This will be the mass of the gas. So this mass of the gas is equal to mass of the rocket multiplied by V of R divided by VR minus V original. So then it will give you the expression and then you will find the answer, which is this one. So the most important thing is that from here we have to use the conservation of momentum. And if the mass of the gas is taking this rocket to this direction, an equal and opposite direction of the momentum should be on the other side so that the conservation of momentum should be conserved. So P initial minus P final is equal. So from this one we can use this expression and then we can find the value which is equal to 14 kg. So this is a question. So rocket of mass is traveling outer space with velocity this one. So alternative direction to original direction. So 35 degrees. So this is the answer.